Hi everyone. Today's talk I'll be presenting some practical approaches for DNN quantization. You might have heard of quantization more than a few times in this summit. It's one of the popular ways of model compression. And in this talk, we'll be going through some of the details and an overview of quantizing deep neural networks. These are the contents of the slide, and the way I try to organize it in bottom-up kind of approach. That is, we'll be looking at some of the fundamentals of the math behind quantization, and step by step, we're looking at the building blocks of these deep learning models and various kinds of design choices that you have when you're trying to quantize these deep neural networks. And also stress on how and what we can do when you have problems with quantization, what kind of analysis tools are available, and hopefully and with the best practices. And that is what I hope everybody who's attending this talk takes away is some of the best practices that you can do to get the best results from quantization. So the fact that you guys are attending, I assume you already understand the importance of quantization. If not, even for the uninitiated, I'll go through just the motivation. So quantization is a powerful tool that enables deep learning models on the edge, especially for the devices that have limited memory and power. This is a broad overview of what you can achieve through these model compression techniques. When you're defining quantization, in this specific talk, I'm going to be focusing on float to int8 quantization, but quantization comes in different forms and sizes. So even the fact that you are able to run a float 32 model in FP16 is one type of quantization. You could convert these FP32 into int16, int8, or 4-bit, and even a binary zeros and ones to get the desired results. For the practical approaches, what we see is int8 is most popular because it shows that you can achieve float point accuracy with int8 precision. And in terms of the latency, you see up to 2 to 3 times increase in latency, especially on the hardware that is able to support int8 compute. Traditionally speaking, it's also more power efficient. And one of the potential drawbacks or side effects that you should be looking for is since you are losing some precision, it might affect the model accuracy. And you need to be aware of this and see what techniques that you can use to recover the lost model accuracy.